Welcome to today's webinar. I want to show you today some tips and tricks using the Navigator and the Printout Report in the program RFEM. And as usually, this is quite analog in R#. So my name is Gerlin Schubert, and my two colleagues, Sandy Matula and Stefan Frenzel, they will help me answering your questions. And in case there are many questions coming in, you will definitely get an answer. Even if you don't manage today, you get an answer the next week via email. So don't worry, just in case. So that's the geometry we are looking on today. And I go to the next slide. So for the new customers today, you see the control panel on the right hand side, and you can show and hide this control panel by pressing the orange arrow button, and you can ask your questions down here. So you can just type in the edit field the questions, and you get your answers the same way, or as I already said, you get an email later on. So just to show you the content quickly, so I will say something to the grid settings, and we will talk about the axis system. We will define grid lines and so on. Then we have a look to the Display Navigator. We have a look to the View Navigator, and we will define user-defined views. We will open and create a printout report. We will adjust the settings in there. So we will use templates and define our own templates, change the selections. We will create cover and headers, and we will print graphics into the report. We will also have graphics in series, and we will insert graphics from the clipboard. And finally, I will open another RFEM file where we use the template that we created earlier, and we will use this. And in another three-dimensional model, I will show you how to use the three-dimensional PDF. So now we go already to the RFEM. That's the production hall we are looking on today. So it's a quite simple and small system, but the principles are the same. So I just show you what I've defined. So I have a load case self-weights and snow and wind and all that on all the directions. I have imperfections in all the directions required. And I've used the automatic combination option in RFEM to create all these load cases that you see here. So I don't explain how the automatic combination is working today. You can see other webinars explaining this, but that's why we have quite many of these load combinations here. And we have finally two result combinations, one for the ultimate limit state and one for the serviceability state. And I did a design analysis in RF Steel according to Eurocode 3. This is an add-on module I've used. So just to give you a wee introduction to the model we use today. But we don't go in any details of the calculation. We just have a look to view settings and printout report, as we said. So the first thing we want to do is define. We have a look into the work plane settings. This is in here, settings of work plane, grid, snap, object, snap, and guidelines. So I just want to show you one option in here. That's the dynamically according to size of the model option. So this is quite nice in my point of view. You always have a grid which is adjusted to the size of your model. So I've used this already. So this is the reason why the grid is stopping just outside of the building. Okay, now we want to define grid lines, so a system of axes, and there are several ways to do this. We can insert guidelines graphically. So, and there is an option parallel to X and parallel to Y. And we can enter a description. So for example, I just make two examples. We finally want to use another option. So I can call this A, and then, oh, I hide this here. And then I click onto this axis and hold on. Yep. Yeah, here you see that's appearing now, the axis A, and I could do another one and click on this and the B is appearing. So, and you can do the same parallel to Y and call it 1, 2, 3 and so on. So I don't want to use this, so I go a step back and another one. What I want to use is insert grid lines, align grid. And this is only suitable for a regular building like we have it today. So I have a span of 5 meters in each of the directions. So if your structure is not regular as this one, not as symmetric, then you might be better using the graphical option I've just shown you. So this is for my structure, this is the best to use because it's the quickest way. So I have a span of 5 meters, as I said. So I enter this here. And this window is working the same way as the main RFEM window. So I can just use my mouse wheel to zoom in and out. And I have, hold on, I switch this on to see what I'm doing. And I want to see the lines as well. So I increased the number of fields. Here you go. 4 of them in direction X, and we have the same span in the Y direction, and I have 5 fields in this direction. So you see the numbers and the letters appearing, and you see also the dimensions. So that's all we have to do. It's just called line grid 1. You can choose a different name, but then I'm happy with this. So I just click OK, and that's what we finally did. We have the dimensions and we have the axis. So we did 2 things in one step, which is quite handy. So, and I want to show you where you can, in case you did something wrong and you might have to change something, you find this here, edit, line grids, and you can edit what we've just did. So I have to select the number 1, my line grid number 1, and then we have the same window again. So I don't have to change anything here, but just in case you need to. And you can also switch the line grids on and off. We have the huge Display Navigator. You have many, many options here. We just go through this straight after. But you can, I just want to show you that you can switch on and off the line grid. And this is here. So under Guide Objects, line grids, and then you can either switch them all off, or you can just switch the line grid 1 off in case you have more than one line grid defined. So that's the way how to switch it off. And so now we go through the Display Navigator more in detail. We have the model up here. We can switch the whole model off if we want. And for example, if I switch on the loads for my load case and switch the model off, then you just, that's all what's left. So, and you can, it's going deeper and deeper and more in detail. So the more you get in, for example, you can only switch off members, then you still see lines, but no members. So there, everything can be switched off separately. So here in the members, you can have, for example, material descriptions. So we have just one material, or you can, this is quite important sometimes, the member access systems. So you get all the local access for each member. And you can also have cross-section descriptions. We will use this later on again. So this might be quite important sometimes. And for the set of members, you can switch them on and off. I've defined set of members here for the upper belts. And you see dotted lines, and this is just showing what members are connected to a set of member, and you can also have the description of the members. So I switch this off. Then you can switch on and off the loads. You can also have the load values on, and you can have load case descriptions or the load case numbers. You can even have show the units of the loads. So basically you can just have a look through, and it's quite detailed, and you can switch on and off everything separately. The same with the results. So that's what I want to have. It's jumping into the results navigator when you switch on the results. but I want to stay in the Display Navigator for now. So for example, when we look, this is load case 1, and we look at the deformations, that's what you see up here. We look at the global deformations in Z directions, and we see just lines. So I switch off the loads that we see the lines better. For example, you could change, it's in deformation because that's what we are looking for at the moment, and you can go into members, and you could also display the deformations on the cross sections and then in a colored way. So I think that's much better in this case instead of the lines, but just as an idea. Also, if I go to the steel, to my design results from the Eurocode 3, I could show the results like this. So that's not as suitable, I think, because you don't see any of the numbers properly, and so much better is it to have the members. So we are still in the result paragraph, and then you can go to members and you can see the results displayed on cross sections as well. And you have the panel on the right hand side here, so that the sign ratio, and you see the colors, and you can obviously, you can change these colors, you can change the scale that is used, and so on. So we want to print this graph later on into the protocol, but for now, hold on, I did want to, we have a look into later on into the FE mesh settings when we have a look to a surface model. What I want to show you right now are the guide objects. I told you this already. You can switch off your line grids here. You could also switch on and off dimensions. You can, in the general paragraph, you can switch off your grid, or you can switch off the coordinate system. You can have a numbering for nodes, for members, for everything. And you can have colors according to specific things. And we can have, for example, I have to switch the results off to see something. We can have the colors according to cross sections. And again, in the panel on the right hand side, you see the different cross sections we are using, and you have different colors defined. And again, you can change these colors to whatever you want. Okay, that's all I want to show you in the Display Navigator. And now we have a look into the Views Navigator. Here, you can define several visibilities, and you can define user-defined views, and all what's available in the Views Navigator is available also here, or you find it here, View and then Visibility. You have the same options in here. So what I want to do is I change to the view in the -y direction, and I select the upper belts. And now I want to only display the selected objects. So what I do is a visibility by selected objects. So and now you see that you still see the rest hidden in the background, so they are not completely disappeared. It looks like this in the isometric view. And we can switch this off by it's in the Display Navigator again, and in the paragraph General here, down here, you can show the hidden objects in the background. And when we switch this off, that's all what's left. That's just the roof. And now we want to define our first user-defined view. So I go into this view and in the Z direction. We are looking in the positive Z direction now, and I define this as my first user-defined view. I call it top view, and it appears now here up in the list, and we can just choose it later on. So we do 2 more views, but it's a similar way. I use these buttons here to cancel the visibility to see all objects again. You have to click cancel, and then we go back to the isometric view. You can rotate your model by pressing the mouse wheel, and then I select this here. It's our axis A. So I again use the button visibility by selected objects, and this is all what's left. And I want to see this in the -x direction and define this as an elevation of axis A. And a third one, we go back to the isometric view, I cancel the visibility, and I select now this part. That's my axis 6. Again, visibility by selected objects. Now I want to have the view in -y direction, and I define this as my elevation axis 6. So we are using these defined views later on again in the printout report. For now, that's all I want to tell you about the view navigator. So that's quite handy. I just show you what happens. I can cancel the visibility. I can go back to the isometric view. And when I now click on one of those, it's just jumping back into what we have defined earlier. So that's quite useful. And I cancel again and to see this. Okay, now it's already time to open the printout report. There are several options again. You have the printout report here, the current printout report, or you can open a printout report here. We do this. So no printout report is existing yet, so we create a new one. And there are several templates available. Depends just on the content. So input data and reduced results is a good recommendation. All chapters leads to a very long report. So, or you can have something concrete specific or steel specific. So the first option is the default and is a recommendation. So you can have a deeper look into the selection of the printout report by pressing this button. And now we have, as we've defined or calculated something in the add-on module RF steel, you have this available here, but usually it's RFEM and add-on modules depending on what you did. So you have the model data, load cases, loads, result combinations, and the results of load cases and load combinations and the results of result combinations. This is okay, I think. Here you have specific choices. Here you can, this is just giving you a list of what kind of load cases and combination you defined. These are the loads. I just want to display, I just want to have information about the load cases here. That's okay. So we can keep all. And here I would rather like to see the member internal forces instead of the internal forces of cross sections. So you can activate and clear checkboxes depending on your choice, depending on your wish. And here I only want to see the load cases just to make the printout report a bit smaller. So I select the 6 load cases and add them. This means only the results of my load case 1 to 6 are shown and not the results of the load combinations. So I have 6 selected cases and member internal forces, and I switched off this. And we go to the result combination results, and here we have 2 and I want to use them both, so I can just go with the all option. And here the same, I want to change to member internal forces instead of cross-section internal forces. And that's all I want to set for the RFEM. Now we have a look to RF steel Eurocode. So usually the choice is quite okay. That's all the default settings, and usually you can just take them. And in case of the results, the pre-choice is designed by set of members and designed by member. And here is a filter setting that we can apply. That's a filter setting defining the design ratio. We come back to this later, as I want to show you how much, how many pages less are finally produced when we apply a filter like this. So for now, I just click OK, and we let the printout report be generated. It takes always a while, depending on the size of your model. So here we go. So we have 170 pages. And so far, we only see tables and numbers, and we will insert some graphics later on. But I can click through a bit. Here you have cross sections and member hinges. So what we want to do is we want to define the header. So we have at the moment, it's just kind of a default header, and I want to adjust this slightly. So when you go to the header settings, you can create a new one. And I just call this Dlubal. And this is already entered. I can take this from the default header. This was set in our case, but you can enter here whatever you want, the company name, and we can have a logo. So we use this company figure, and we use today's dates, and I want to change the project name to webinar protocol and views. Okay, that's too long. I'm not allowed to do this, so we just call it webinar protocol, and I change the name of the model to, that's the production hall. So click OK, and we see what's actually changing. So double check that we have made the right choice here, Dlubal, and now we have the logo up here, we have the company name, and we have changed the project name, and we have changed the model name. So that's this. Now I would like to have a cover. So I can enter the project name. Usually you have to type in here a bit more than I'm doing now today, but just to show you how it's working. So it's for you, our customers, and the engineer, it's me today. You can change always fonts and colors and sizes, and so the thing you're used to. So we want to show the cover sheet, and we want to show a picture of the model on the cover sheet. So that's the cover that we just generated. And on the next page, then the model general data starts. So you can change the language. It's independent of the program RFEM, so you can have a different language in RFEM than you have in the printout report. We have 12 languages available. I don't change this here right now, but just to let you know that you can adjust the language. So even if you work in a different language in the program, you can adjust this here. Then I promised that we have a look again into the selections. You always get to the selections when you use this button, select topics for printout report. And we wanted to have a look to the filter option. So I want to define a ratio of, that's the design ratio I define here, so 80%. I want to just see all the members that I used more than 80%, and I want to apply this filter for these two sections here. So remember we had 170 pages. When I click OK now, the report is generating again, and it should be less pages. So I think, yeah, we end up with 150 pages, so 20 pages less just by applying a filter like this. So what I want to do now is I want to show you how to insert a text block. This is, for example, when you have a description, an introduction, abstract, or whatever that you want to show on front, or even if it's in between, you can insert text blocks. And I've prepared something. It's just a blind text, so it's nothing special. So I just copy this, can close this, and I have this text in here. So it's just to show you how this is working, and I call it introduction, and I want to display this over the full page width. So I tick this box, I click OK, and what happens is that new entries are always coming at the end, but you can apply drag and drop. So I can just click this and move it wherever I want it to, and I want to have it just below the cover. Yeah, so we have the cover. On the next page we have our introduction, and then the model generator data begin. I don't like this on the same page. I can just go on this, click right, and start with new page to change this. So now I have only the introduction on this page, and on the next page the general data starts. So this is what we want to save now as a template. When you save templates, you can use this in other RFEM files again. So we recommend to do this before you insert any graphics or images. So it's when you define the cover sheet, and so like this now, it's a good point to save this as a template. You go to settings and you have printout report template, and you can create a new one from the current printout report. You give it a name. I call it Dlubal cover and introduction. I save this, and later on when we open another RFEM file, I show you that you can use this and show you the effects. Okay, now we want to go ahead and print some graphics into the report. So I save my report and close it. I want to print this graphic as shown, so the cross sections are colored, and I want to print this graphic. You can either do this with this button, print graphic, or you can go to file, and here it is as well, print graphic. And we want to print it to a printout report. We want to use 50% of our page height. We want to print the current image only, and we want to have it window filling, or in this case it would be the same. You can also use a screen view. And I don't want to call it model, I want to call it cross sections. And here it is now. It's inserted on the nearly right place, so within the model, because it belongs to this chapter, but I would like to have it just below my section cross section, so that I have the description in a tabular view, cross sections, and just below I have the image. So, okay. I want to print another graphic. So the one I did show you earlier, the results of my steel design analysis. I want to print this. I use the button this time, and I don't want to show the printout report afterwards because it always takes a while to generate, so it saves some time if you clear this checkbox. So the same settings apply. Design ratio is a good choice, so I keep this and I just click OK, and basically nothing happens, but it is printed into the reports. Okay, now we want to do a print. We print a whole series of images. So I want to print all the loads, and we also want to print a few, just the model in certain views. Yeah. So we go into print graphic again, and this time it's not the current only, it's a mass print. So we print series, many images in one step. We want to have it window filling again. The height is okay. The setting is nice because so this way you get 2 images on one page. And just to look through here, you have several options. You can change the factors for whatever. Yeah, here it is. That might be quite interesting. You can insert the number of pixels. So to increase the quality, basically, you could choose this one, but this is usually sufficient. So it depends a bit on your needs. We keep this setting for now, just to show you this. You can change something on the color scale. You can change factors, deformation factors, for example, and you can adjust the borders, or you can even stretch or compress the image. So we go with the standard setting here today, and we go into the options now to define the series, to define what we actually want to print. So we want to print the model in the views in the directions X, Y, and Z. I don't want to print the isometric view because I did this already. And I want to print the load cases with its loads. So I think it's much better, instead of just having the tables with all these numbers, to print these graphics in here. And I don't want to have all load cases and combinations. I just want to display the load cases. So I have to go to selected here, go onto options, and then go in here, and I select my load case 1 to 10, get them over here, click OK. And the current view is okay. That's the isometric view. We just go with this, and I don't want to print any results today. So what we get is 10 number of graphics from the loads, and we get 3 graphics from the model, so 13 at all. So we click OK, and now I want to show the printout report after I did so, because we want to double check. It's quite many pictures we print right now, so we want to double check what actually happens and where they are placed and so on. So this takes a wee while. So this is what we did earlier, the cross-section image. Then we have now the model in X direction, the model in Y direction, and in Z direction. So, and here I promised that we come back to our user-defined views, and that's now the place where I want to do this, because here our user-defined view is better because we don't see all the members from the background. So I click right on this image, I go to edit, and what it does, it jumps into the program RFEM, and I go to my views. I select this one, the elevation axis A, so in the direction X, and now I just click back, and it exchanged the figure. So I do the same with this one. Hold on, I want to rename this. So I click right on here, go to properties, and call it the same way as we did it with the views. Okay, and I want to do the same with this image here. It's in the direction Y, so I go to edit, it jumps again into RFEM. I go to my elevation X6 and go back, and it automatically changed the figure. So again, I change the name, properties, and then elevation. Okay. And we do the same with the last one. Again, right click, edit, we change to the top view, and that's it, back. No, that was not all I wanted to do. I go back into RFEM. I wanted to switch on the cross-section descriptions. I did show you this earlier, so I would like to switch this on. And I don't want to display the colors according to cross-sections, so that's quite far down. So I go back to colors according to standard. And now I go back into the printout report, and it did adjust the image. Now it's quite small because we can't really read the text in here. So what we have to do is go to properties. I call it top view, and I want to use the full page height. So now it's much better. We can read the text, and so we need the full page. So we have a look again, our tables, and then the following graphics. So then we inserted as well loads figures. So you have now for all the load cases, 10 load cases, you have graphics showing the loads. So below the table, you have a graphic now, and it's automatically sorted on the right position. And if not in some, then you just use the drag and drop as I did show you earlier. So this, we didn't have a look to this image yet because we did not open the printout report. This was the image we printed earlier. So we are nearly done. What I want to show you again when you click right, you can also remove single things from the report. You can also, when you go into properties here, it's a local choice then. And up here, this is a global selection. So this is a quite important difference. And for example, this member table is a quite long one with not that much information as I find. So I could, for example, just remove this from the printout report. It's double checking and I just say yes. And so finally, once we insert all the graphics we need, we end up with a protocol of 160 pages, and this is quite reasonable size. You can even decrease the size. So I want to save this. Yeah, there's one more thing I want to show you that's quite important. You can also insert figures from a clipboard. So for example, if you did some handwritten calculations that you would like to insert, or even if it's a table which you really miss in the report and that you can't find in all the global selections we did so far from a special add-on module, you can make a screenshot of it and you can insert it from the clipboard. So there's one trick. You have to use the program Paint. Paint is a usual Windows program, so it should be available on all your computers. And we have the German surface here, and I use also the German, it's a German snow map, so we are a German company, so that's why. So, but we choose all. What I'm doing now is select all, and I copy this. This is the way how to get something in your clipboard. And once you did this, we can go back to the protocol and I insert an image from clipboard. So you can do this with any kind of image, and I call it snow map. And at the same way as the introduction, it's sorted at the final end because it doesn't know where it belongs to. And now we can just move it. I would move it to the load case 2, which is the snow load case, and I move it up here. And we have a look. So that's the load case 1, and the load case 2 is here. Load case 1 self weight, and then you have 3.2 is the snow. It's the description is on the left hand side here, and then you have the snow map that we just inserted, and so on. You have the image that we inserted earlier. So I think that's us done with the report in this file. So I save it and close it, and we open now another RFEM file, which is a surface. I did open it already. I go to data, go to the far bottom, and it's just a concrete surface. It's a reinforced concrete, and I just show you quickly. We defined some load cases. We have again load combinations, and I did a design in RF move surfaces. So we have again result combinations, and we have results from the concrete design. So what I want to show you is these are the results of our result combination 3, and you could in the Display Navigator you can adjust the FE mesh settings, the display of the FE mesh. So have to scroll down. Here it is. That's this paragraph. And you can either see it on the surface directly. That's this. So it's under the undeformed shape, or you can have it on the surface results. So the difference is that it's now kind of smooth to the deformed shape. And when we can have an animation, which is up here, and now you see the surface deforming like this. And when I now switch off these colorful ISO bands, then you see how the finite element mesh is deforming up and down. Just as an example. So I stop the animation, I switch the graphic back on, and that's an image I want to print in the printout report. So we did this already. So I print a graphic. This time I want to have a 60% of my page height. I want to print it into the printout report. I don't want to change any of these other settings. And now we will see that we don't have a printout report yet, but we defined a template earlier. That's the Dlubal cover and introduction. You could use the default template, but this is the reason why we defined it. I want to show you how this is actually working, and you can reuse your cover and everything what you already set. And so I choose the number 7, our own defined template, and I click OK. And the report is generating. So it also keeps in mind all the selections we did, that we want to see a member internal forces and not the cross-section internal forces and so on. So, okay, that's the figure. So I'm quite, that's not the figure I wanted. Here it is, I think. Yeah, here it is. That's the figure I was looking for. That's the global deformation. It belongs to the result combinations. So this is why it's in the chapter of result combinations. And this one, I removed this for now because I don't want this right now. Okay. So far it's just 30 pages long because we don't have as many results. I save it, and we want to have a look to the concrete results itself. So I close it, and I want to have a look to the RF concrete surface results. So here we go. On the result navigator, you can have a look to the required reinforcement, and you can have a look to the AS1 top reinforcement, the same way as to the AS2 top and bottom. And always have a look to the panel on the right hand side and where you get the numbers. So what we are actually looking on, the meaning of the colors. And you can not only see the required reinforcement, you can also see the required additional reinforcement. What I did, I defined basic minimum reinforcement. And when I switch to the required additional reinforcement, it's just showing me what it's added on top of the basic reinforcement. So I changed to this view, and I want to print some of the results figures in series again. So similar to what we did already, I want to print a graphic and I want to do a mass print. I want to only show some results of selected cases, which is only my RF concrete surface case. Click OK, and I want to see the required additional reinforcement, the required reinforcement, and I want to see all of the reinforcement graphics we were just looking on. So yeah, that's it. I click OK, and I want to see the printout report after we clicked OK. So again, it takes a while. So this is our, wait, yeah, here we go. That's the cover. That's because we've used the template, so we don't have to define all this again. We have still the logo and the company name, and you have also still this introduction. That's because we've used the template. And now at the far bottom here, we have all these images, that we produced. So, and you see now that they're a bit too big to be, so I want to have two, I want to change the properties to 50% of the height so that we have less pages. So they should now fit on one page. So that's what they do. So, and that's all I want to show you here. So that's just the way how you use a template again to save some time. And you can either print the report directly to a printer. You can export it to an RTF, which can be used in Word, for example, or you can export it to a PDF. We have also an export to VC master. So, and the final thing I want to show you is how to print a graphic into three-dimensional PDF. And therefore, I have prepared another file, which is just quite nice one to see in a three-dimensional PDF. So it's just a pipe, what we see here, and we see some stress results. It's the stress, yeah, it's coming from the module RF steel surfaces, and it's a quick thing. We want to print a graphic. I want to just print the current only, and I want to print it not into a printout report this time. I want to print it to a 3D PDF. And I have to provide a name. I save it, and it should open automatically. Here we go. That's a strange PDF reader. I hope it works in here. No, it doesn't. I close this and I go to my folder. I open it with the Adobe reader, the common one. And oh, yes, please. Sorry for this. So I increase the size, and now that's a three-dimensional PDF. I find this quite amazing. So you can rotate it in here by using this. Activate it, yeah. Hold on. Yes. It's just with the left mouse button, and you rotate it. So it's a quite nice way to share your results with a colleague or something, and people who don't have RFEM available. So this is the final thing I wanted to show you, and I just go back into our slides. Here we go. So, and I just want to say thanks for your attention. Many thanks. And if you have any questions, just let us know. My two colleagues are still available, or you get an email on Monday, and you can always visit our website if you have further questions, or you can follow us online. I really recommend the Dlubal blog. We post something daily in there, new features we have or things that are explained in more detail. You can always write an email or call in. And we already prepared another webinar. It's coming in July, and it's about analyzing timber connections by using RFEM and AirStab. So anyone who is interested in timber connections can listen to the next webinar. It's already on the website, and you can register. The appointment is the 2nd of July, and there are more webinars coming later this year. We try to have one every 2 months roughly. Register here, and I thank you again for your attention. Many thanks. Bye bye.